everyone, and welcome to our video on solving basic trigonometric equations. So our goal in these problems is to have the trig function all by itself. And then after it's all by itself, we'll use our unit circle. So we want whatever the trig, so I just wrote trig as like sine or cosine or tangent or whatever, of theta equals a constant. So we want that to be just like how number one is. So we have the trig function equal to just a number. And then afterwards, we're going to use the unit circle. So let's see how it works in this problem. So since we already have the trig function by itself, sine of theta equals 1/2, we're using the ideas of inverse trig. Now, we don't really want to introduce inverse trig if we don't have to. What we're doing is saying, well, this is a y-coordinate. Since it's a sine of theta equaling a number, that number is a y-coordinate, and I want to find that on my unit circle. All right, well, I know I have a 1/2 right about here and a 1/2 right about here as my y-coordinates. So there's the square root of 3 over 2 and 1/2. And then here's the negative square root of 3 over 2 and 1/2. Now, most of the time I won't go and put the full point. I usually just do a big old dot. But now that I've got these dots for this problem, I am going to label the angles. So close to the x-axis would be our angle with 6 in the denominator. So there's pi sixth. And then this one would be 5 pi sixth. And so what we'll do is we'll write those answers, but leave it with a little, well, actually, we'll just write those answers. So all we do is now say, well, that's the angle in the purple that would satisfy this equation. So theta equals pi sixth, 5 pi sixth. Now, depending on how they want us to write the answers. So on this problem, it says solve. So that means we will find all solutions. That's not what we currently have. So this answer right here, then I'm going to cloud. And they might want this anyway on other problems. These are the answers on 0 to 2 pi. Okay, so using our radians, that's 0 to 2 pi. Now, all answers, all we have to do is take the answers that we found from 0 to 2 pi and put an addition of 2 pi k. So we will take pi sixth and do plus 2 pi k, comma, the other angle, 5 pi sixth, plus 2 pi k. And then that's solving the equation. That's all of the answers that they wanted. So these are all the answers. So that's solving. Okay, so we did solve it without any interval that was given. So we solved just like that. Okay, and the reason we add 2 pi k to those answers, let's mark it in blue, is because we know from pi 6, if I went around once, that would be adding 2 pi. If I go around again, that would be adding another 2 pi. If I go around again, another 2 pi, and so on and so on and so on. So the k is an integer. So what k means, I'm going to squeeze it right in this area. So k is an integer. So it says it here. I used in, that should actually be k there. Sorry, so I need to fix that. It'll be fixed next time. Let's change that to k. They might use in as well. That's why I did it. So I think I switched my mind in the middle of that. But anyway, so k is an integer, which means it's dot, 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 -2, -1, 0, 1, 2, so forth. So it is just adding or subtracting 2 pi to our answers. All right, so that's all of what that means. Now, it did say write our answers in degrees. I'm going to do that for number 2. So number 2, let's do radians and degrees. So for number 2, our goal is to get the trig function by itself. So we want that to be isolated. So that means we should subtract 4. So we would have 2 secant of x equals -4. And again, I want the secant of x all by itself. So that means at this point, I should divide by 2. So I'd have secant of x is equal to -2. Now, secant, I don't really like. I can instantly change it into a trig function I do like, though, with reciprocals. So if I change secant into cosine of x, that means I can flip the answer to be -1/2. And then that's easier to work with. So on my unit circle, I'm thinking, all right, where are my x coordinates -1/2 since I'm dealing with a cosine function? And well, I would have a -1/2 in the second quadrant and a -1/2 in the third quadrant close to the y-axis. Close to the y-axis is where we would have 3 in the denominator. We would have 2 pi thirds and we would have 4 pi thirds. Okay, so our x value, let's go ahead and jump straight to our all solutions. So we're going to take those two answers and add 2 pi k to it, and then comma 4 pi thirds plus 2 pi k. Okay, so there's our radians. Now radians are the ones that they usually want more of, but they might ask for degrees. So real quick, in the blue ink, I'm going to say, well, 2 pi thirds, we can convert that, or if we're really good with our unit circle, we know that that's 120 degrees. 4 pi thirds, again, using our unit circle or converting, we would say, well, that's 240 degrees. And so our answer for this, actually, let's keep it in blue. I'm going to put it right here, would be 120 degrees plus, now instead of 2 pi k, we would need to change it to degrees, so we should add 360 degrees k. And then we also have comma, the 240 degrees plus 360 degrees k. Okay, so we have those two answers. So that would be if they wanted it in degrees versus radians. All right, so if they don't specify, then I guess you can choose whichever one you want, but it would probably be assume radians. Okay, and that's it. That's how we can do these problems. Now, what's really nice about these, you can double check just like you could for any equation. So for instance, if I did plug in 2 secant of 2 pi thirds plus 4 and equal to 0, so that's like what we did in the previous video, we could double check all of these. Now, secant of 2 pi thirds is -2. And yeah, 2 times -2 plus 4 is 0. And then we could check the other one as well. It would also work. And we could check our answers from number 1 also. So to save some time, I'm not going to check everything. But that's a way to always know if you're right or wrong. In any equation, take your final answer and plug it back into the original. All right, so that's it. We'll take a look at another couple in another video, but thanks for watching. See you then.